Okay, here we have another fundamental theorem of calculus question. They've given us g as it relates to f of t and h as it relates to f of t, but they match the same graph. So the first question says, how are the values of g and h related to each other, and give a geometric explanation. So what this is still saying that g prime of x is equal to f of x. And this is saying that h prime of x is equal to f of x. So basically they have the same derivatives. So how are the originals related to each other? Well, they're really the same equations with different constants. So they've been shifted up and down. So that's really A. And just to verify, if I had something like 3x squared plus 2x plus 7, its derivative is going to be 6x plus 2. Well, if I had 3x squared plus 2x minus 4, its derivative is still going to be 6x plus 2. So this is the idea that one is g, one is h, and they have the same derivatives. So that's really what has gone on here. Now when we work with the numbers, we'll have to be careful about that, how it's described with that bottom level. And there is one kind of tricky part here I really don't like in terms of a verify. Okay, let's keep going then. Alright, here's part 2 on which subinterval is h increasing. So we're thinking about h, but it's not going to be too big of a difference here. So this is h prime and h. Now I'm going to look at these critical points here. We have -3, we have 1, and we have 5. And we want to show where it's increasing. Well, before -3, we have positive numbers, so we are increasing. Between -3 and 1, all of our derivative numbers are negative, so we are decreasing. And between 1 and 5, all of our numbers are positive, and we are increasing. So it looks like, when are we increasing? We're increasing when x is, we'll say, greater than or equal to -5 and less than 3. And when x is greater than 1, less than 5. All right, now here's the one that I really don't like on this particular question. Verify g has a local maximum at 1. Well, it actually doesn't have a local maximum, so again, I don't know if there was a typo or if something was going on here, but if this is g, then this is g prime, and at 1 we are actually going from negative to positive. We're going down and up, and it will have a local minimum at 1. So it doesn't have a local maximum at 1. It has a local minimum at 1. And that's really, like, what the numbers are will be different, but it is going to be, it's a minimum value. All right. Okay, for these next two sections, I'm actually going to kind of solve them at the same time, because they're the two functions g and h are related to each other. They're just kind of shifted. They're actually going to get their minimum and maximum values at the same location. It's just what those minimum and maximums are going to be. So if we look up here at -3, 1, and 5, those are kind of our big things, and then we'll do one out here maybe at -5, just kind of where we started. We can see these are all positive numbers, negative numbers, and positive numbers. So we get this kind of shape. We can see the minimum values are going to be at 1. Maybe we'll check -5 too, just to verify which one is actually going to be the minimum value for both of these. Okay, so let's go and see what 1 is for each of these cases. So if I go here with g of 1, I'm going to get the integral from negative 3 to 1 of our function. I'm just going to abbreviate here. So negative 3 to 1 is all of this semicircle here. So the radius is 2. So that is pi r squared. So the whole circle would be 4 pi, but I only have half of it, so it's 2 pi, and it is below the graph, so that is negative 2 pi. Let's try h of 1. Well, h of 1, according to its equation now, is from 1 to 1 of our function. Well, anything 1 to 1, if the two endpoints are the same, that is actually 0. Now let's just verify that maybe 5 was the minimum here. We can see we start to go up from 5. So maybe 5 was a lower minimum. So we are going to test those just to be safe. So I'm going to do g of 5. And that would be, sorry, negative 5. That is negative 3 to negative 5. Okay, well I got to flip that over here. Let me just slide some of this stuff up and I still want to kind of refer to that graph a little bit, but we're going to have to flip this over then and get negative 5 to negative 3 of our function. So the opposite of our function. So again, if we look at the graph a little bit, we're talking about this area right in here. Now, I'm going to guess that maybe this is at 3, but I'm going to get 2 times 3 divided by 2. I'm going to say that has an area of 3. So if that has an area of 3, this is going to be minus 3, and negative 2 pi is actually bigger than minus 3. How about h? If we go h of negative 5, that becomes 1 to negative 5. So again, I'm going to have to flip that over and say I want to go the opposite of negative 5 to 1. Now I got a lot of things going on. I'm actually going to split that up too because it has 2 parts here. So it's really like the opposite of, I need negative 5 to negative 3 plus, that's a 3, plus the integral from negative 3 to 1. I'm going to get that whole area, and then I got to make it the opposite of that. Okay, so I got to do the opposite of that. So this is still, the areas are essentially the same. So I'm going to get, I know this is getting quite sloppy here, but the area from negative 5 to negative 3, if you look back on that, was 3. The area from negative 3 to 1 was that circle underneath, which was negative 2 pi. So we actually get this part here is, if we think of that as 6.28, we get negative 3.28, or if you just say negative 2/3 pi, or no, let's do that. So that's going to be positive 3.28. I kind of drifted there. So that's positive 3.28. Now let's go all the way back up. We had 0, which is smaller than positive 3.28. So in fact, the minimum is at 1, and the value is negative 2 pi for G. And for part the last part here, for part E, it is 0. Okay, and I know that was getting a little messy. Let's see if we can clean some of this up and get rid of a bunch of this stuff here. Okay. All right. So let's look at where we get the maximum values. Okay, so we want the maximum values. So maximum values are going to occur at 2 possible places, negative 3 and 5. That's where we're going to get our, that's where we're possibly going to get our maximum values. Let's look at that chart again, right? Because we were at negative 3 and 1 and 5. We were positive, we were negative, and now we're positive. So it looks like negative 3, maybe negative 5, or sorry, maybe positive 5. So that's where we got to check here. So I'm going to go and try G of negative 3. Well, that, according to our graph, is negative 3 to negative 3. That's just going to be 0. So that has a 0 here. How about, just to check, g of 5? So g of 5 is going to be from negative 3 to 5. Well, I'm going to split that up into negative 3 to 1 plus 1 to 5. So I'm looking at two areas here. I'm looking at the area of my circle and the area of this, and we're going to put them together. Okay, so that becomes, again, from negative 3 to 1 was negative 2 pi. And then this here, base is 4 times height is 2, divided by 4, that is plus 4. So I get negative 6.28 plus 4, it looks like negative 2.28. And we can see that 0 is actually bigger than that. So the maximum value for g occurs at negative 3, and the value is actually 0. Let's try that whole thing for h. So same setup. I'm going to try negative 3 and 5. Those are my two possibilities, but now we're working with h. So I'm going to go h of negative 3 is going to be from 1 to negative 3. Okay, well, I got to flip that over, the opposite of negative 3 to 1. Well, negative 3 to 1 was all of this part here, which was negative 2 pi. So if I take the opposite of negative 2 pi, I'm going to get 2 pi. Let's make sure, and we're going to check 5. So h of 5 is the integral from 1 to 5, and that will just be this in here, base times height. 4 times 2 is 8, divided by 2 is 4. So 2 pi is greater than 4. So in both cases, the maximum is also occurring at negative 3. For h, though, it is 2 pi. So what are the values? The maximum is 2 pi. Remember, the maximum here was 0. Okay, so it was pretty good. It was this question here that I thought was a little silly because g does not have a local maximum there. It has a local minimum at that point. I don't think we do something like that. Like, I can't recall exactly where I got this question from. It was not from a calculus exam, though. And sometimes my textbooks do have typos in them too, but there's something going on there. Okay, hopefully that helps.